Hi everyone, welcome to Keras Nights, a show about making deep learning easier with Keras. Tonight, I'm joined with amazing gents and ladies who are going to take us, who are going to give us amazing, are going to talk to us about amazing things in Keras. And I'm going to invite Daisy. Hi Daisy,
Hi, Ngesa.
how are you?
I'm good. How are you?
I'm doing well. How is your evening coming along?
My evening is coming along nicely. I had such a good day, very productive day, and I'm super excited to be here to share more about Keras and what more the community can learn. Yes.
Awesome. What's the plan for the evening?
Great. So tonight we'll be hearing from yourself, Ngesa, the GDG lead for Nairobi, just for you to tell us more about Keras Night and what the session really will be about. We'll also be hearing from Philomena, a WTM lead and a Women in Data Science ambassador. She'll talk to us more about data and what opportunities women can leverage in this space. And then finally, for the guest of the day, we'll have Aritra, a deep learning educator at PyImageSearch, who really is the guest for the day, and he'll be talking to us through Keras, Jax, and really how the community can use the two in deep planning. Over to Ngesa.
Thank you, Daisy. So, Keras Nights again is a show about making deep learning easier. And we discuss ML papers. We bring GDEs on sessions like this to talk to us more about Keras. We also have ML study jams. So we just finished I think the third ML study jam for GDG Nairobi, of course, in partnership with other communities. And just generally that one, being able to talk to people about what we love, and that's Keras. Yes, Daisy.
Thank you, Ngesa. And now I'd like to introduce Philomena, a data scientist, a WTM ambassador, and Women in Data Science ambassador as well, just to talk to us a bit more.
Hi everyone. Thanks Daisy. Thanks Ngasa. So I'll just tell you a bit about WTM. So WTM is an initiative of Google that provides visibility, community, and resources for women in technology. So there's two ways you can be involved with WTM: as an ambassador or as a member. So as an ambassador, you can contribute in four ways. You can come up with resources, whether it's through vlogs or blogs. You could mentor others, you could speak at events, or you could, mentor, speak, or you could organize events. Yeah. So, and as a member, you can be able to take part in all those things as well. You don't have to be an ambassador to do any of those things, but as a member, you're able to tap into those resources that are organized by the different WTM ambassadors. For women in data, locally, I'd say here in Kenya, we have monthly meetups where we're able to meet and discuss anything to do with data, Keras and anything in data. So we usually do a meetup at iHub Nairobi and every third Saturday of the month, and you're all welcome to join. Thanks, Daisy.
Thank you, Philomena. Mark your calendars, ladies, or as Boyle likes to say, serve the date. So, Philo, you got that one. Um, thank you so much, Philo. Also, just to mention, Philomena will be one of our amazing hosts tonight. And finally, to introduce the guest for the day, we have Aritra, who, as I've mentioned, is a deep learning educator at PyImageSearch, and he's also a contractor at Keras. He's an avid open source contributor who likes to break down academic papers into digestible and intuitive blog posts. Welcome, Aritra.
Thank you so much. Thank you for having me. Right. So should I start right away? Cool.
Yes.
All right. So hello, folks. Thank you for joining. I am Aritra. I am a deep learning engineer and an educator at PyImageSearch. I've been doing a lot of Keras and also have been a contributor to the Keras core library. So
Aritra, can you hear me?
Yeah, I can. Is there a problem with the?
I
Guess
think the screen is frozen.
okay.
We can hear you, Daisy.
Okay. Aritra, if you can hear us, please. Your screen is frozen, so you can take some time to fix that, and then we can.
Is it okay?
Okay, but we can't hear you.
Oh, can you hear me now?
Yes, I can hear you, Aritra.
Oh, okay.
Okay. Should I go ahead with the presentation?
Yes, please.
Cool. So sorry for that glitch. What we are going to talk about today is Keras 3, and this is the all new rendition of Keras. And as you can see here in the first slide, this slide is something which is created by me and one of my fellow Keras cohort, who is Akash Kumar Nain. And unfortunately, I'm going to be the only person you see on screen, and all credits to him. So just adding him on the screen.
Is the audio clear on your end, Daisy?
No, I'm really struggling to hear. Ngesa, can you get Aritra clearly?
Yes, I can hear you.
Okay. Perhaps
Okay.
let's try leave and rejoin. Sorry about that.
Yes, sorry.
No worries. No worries.
You're
Okay,
clearer
we can
now.
hear you.
Okay.
Cool. Should I continue? Is it fine? Yeah. Okay. So what you
Yes.
expect in this talk is what is Keras 3 and why you use Keras 3, advantages of Keras 3, and a bit about JAX with Keras 3. So turns out that people who used to know Keras, they knew that the backend to Keras was TensorFlow, but with the all new rendition of Keras, that is Keras 3, we can harness any backend you want. So TensorFlow, JAX, PyTorch, as well as NumPy. So everything comes off the bat. And I don't like just theory. So with the theory, I'm also going to cover a code example with JAX backend. And we are also going to understand why JAX is something which is very nice to have in the Keras workflow, and also why it's going to take us places. So without further ado, what is deep learning? So when a person comes to me and talks about Keras or maybe just PyTorch, TensorFlow, whatnot, I break them down deep learning into tensor manipulations first, and all these things that I named, that is TensorFlow, PyTorch, or JAX, these are all numerical libraries that do tensor manipulation, and that should be the crux of everything that you understand right now. And we will kind of base this foundation and talk more about why numerical libraries are so good and why we need them. So deep learning is just tensor manipulation, and with a little bit of code, what you could do is you could express a mathematical expression which has a bunch of weights, bunch of biases, and everything works off the bat. Now, something that you might know as a deep learning practitioner is that these weights and biases are just tensors, but they also update, as in learn, deep learning. So they also learn based on the input and the output that you give the model. So, say for example, you have an image with dogs and cats, and you want to predict from the model whether the image has a dog or a cat. So the model has a bunch of weights and biases. The image comes in with the weights and biases. You do a bunch of tensor manipulation and you get a prediction. The prediction can be right or that can be wrong. So with the wrong prediction, you get a loss. And with the right prediction, you get a loss which is closer to zero. And with this loss, you kind of update your weights and biases to get this loss as down as to zero so that your predictions are right. So how do you do that? You do that by calculating the gradient of weights with respect to our loss. And then you do something called back propagation. And with the back propagation, you update these weights and biases. So a lot of jargon, let's do a little recap. So deep learning is nothing but tensor manipulation. Weights and biases are all tensors, and we manipulate the inputs with the tensors, and you get an output. Now, with the output, you have a loss, and you also want your weights and biases to give as low the loss can go, right? You need a good model which has learned from the data that you're giving in. So with the gradients, that is del loss with del w, you do a backprop. So there are two possibilities that there are two things that you have got to understand now. That is tensor manipulations and weight updates or gradients. Tensor manipulations can be handled with any numerical libraries. You can also do a basic NumPy and everything works. But with gradients, you need something called automatic differentiation, because let's face it, if you have a very big model, so say for example a 70 billion model, you can't handwrite your entire differentiation in a rough notebook and then update your parameters, right? So you need some program to already do this for you. And the some program that I'm talking about is automatic differentiation. This algorithm is called automatic differentiation. And TensorFlow has tf.gradient tape. Torch or PyTorch has torch.gradient, and JAX has jax.grad. So all of these numerical libraries has their own automatic differentiation engine that helps you do this. So all these updates are going to you don't have to understand how these updates work, but they just work and they have been tested a lot. So all the gradients that you can possibly gather, tf.gradient tape or torch.gradient jax.grad takes care of them. Now the common problem that everyone was facing is, what if we have a common interface to leverage them all, so we don't have to go into this war of deep learning libraries? We can harmonize and make one union to cover all of them, and that is where Keras 3 comes in. So Keras can be thought of as a user interface to all these backends, and these backends are JAX, TensorFlow, PyTorch, and NumPy. So Keras can harness any of these backends right now. You just have to initiate a environment variable and set that to your favorite backend, and everything works off the bat. So what happens now is that Keras can be thought of as a separate entity rather than being coupled with all these backends. So what I'm talking about here is that it's a full rewrite. It has no technical debt, so you don't have to understand TensorFlow, you don't have to understand Torch, you don't have to understand JAX as a prerequisite to understanding Keras. It works as is in a separate domain, and you just have to attach a backend to it. And it's much smaller code base. So right now, if you go to github.com/Keras team/Keras, where Keras 3 is currently being worked on, you see that the tf.Keras, that is the legacy Keras, has been smaller in size. It has compressed from 43k lines of code to 3x times smaller. So it goes down a lot, and this helps you into navigating code very easily, right? That is the first point. The second point is supports multi backend, which I am a very big fan of. So any backend that you like, you can just attach it to your Keras UI, and everything works. And it's also a drop-in replacement for tf.Keras. So worry not if you are coming from the legacy Keras, that is tf.Keras. You just have to change your imports to Keras core as Keras, and everything works off the bat. You don't have to figure out that, hey, this does not work, that does not work, and what are the API documentations, how do I do this? You don't have to take care of anything, we already have. So it's just a drop-in replacement. And there are two sibling libraries that I am really a big fan of, that is Keras NLP and Keras CV. So turns out that Keras is this mother repository for which Keras NLP and CV are based out of. And as the name suggests, Keras NLP is a library that talks about natural language processing, and CV is a library that talks about computer vision side of things. So due to the fact that Keras NLP and Keras CV are based on top of Keras, all the two libraries are backend agnostic as well. So what happens now is that if you have a PyTorch code lying around and you want to play with a JAX model, you can do that. If you have maybe a tf.data dataset pipeline on your laptop somewhere working around, you can always use a PyTorch model or maybe a JAX model or a TensorFlow model, whatever, and you can just seamlessly insert that data pipeline into the model and the model is going to work. So that is some kind of magic that Keras 3 comes in baked, right? And what do I mean by rewrite? So Francois Chollet, who is also the creator of Keras, did a small tweet about the lines of code that went down from 135K to 43K, which is about 3 times the amount of Keras code that was there in TensorFlow.keras. And what dropped is mostly TF1 technical debt. So all this TensorFlow 1 code that we don't need anymore because everything is backend agnostic, we can just leave them aside and create Keras as a beautiful API all on its own. Another beautiful thing that happens right now is that there is this one script in which you import Keras, you build a model, you compile the model, you fit the model, you evaluate and also predict on the model. And this one script can work on any of the backends that you have. So be it TensorFlow, be it PyTorch, be it JAX, you just have to run Python example.py and everything is going to work. And as I said, it's a drop-in replacement for TensorFlow. So if you have code lying in which has this import from TensorFlow import Keras, you can just write import Keras, or you could also write from Keras core. Import Keras core as Keras, and everything is going to work. And as I suggested, Keras CV and NLP both come in baked with Keras 3, so everything works. Now, why use Keras 3? You might ask me. The first one is that it's one API. So it helps avoid the fragmentation in the ecosystem. So there is no war between different deep learning ecosystems. You just need to learn one, and everybody is going to get your models, also going to evaluate on your models off the bat. So it's not a problem. It's a seamless switch. So if you, for example, have TensorFlow in your laptop or your workstation, and you want to get a JAX model and you want to train it somehow, you can do that. So it's just switching from one framework to another, and that is that easy. And there is something called Keras.ops, which is very interesting, at least for me, because what this Keras 3 comes up with is that it has its own native operations, which mimics the NumPy API. So everybody coming into deep learning or machine learning, they have at least heard of NumPy or maybe even went into the NumPy APIs. So if you have very little to no knowledge of NumPy, but just know that, hey, this is NumPy, I can recognize this, you are good to go. You're good to go with Keras, because Keras.ops absolutely mimics NumPy API and also has these extra functionalities for building a neural network. So you don't have to go into the documentations of too much of TensorFlow or JAX or Torch. You can just go into Keras. If you have a background of NumPy, that's very good. Even not, you don't have to fear. You just go into the documentations, see what there are, what there are not. And also, it's a vibrant community, as my hosts have already spoken about. So go to Keras and everything is going to be taken care of. And last but not the least, it's very highly customizable. And that's one of the philosophies of Keras. So let's talk about them one by one and then go into the code. So one thing about Keras 3 is that it is backend agnostic. So you just have to import OS and you have to set this Keras backend environment variable to TensorFlow, JAX, or Torch. And as soon as you do that and import Keras, it knows which variable or which tensor to derive from the backend. So as soon as you do TensorFlow, it does a tf.tensor. As soon as you do a JAX, it's an array. Torch, it's a tensor again. So everything is going to be taken care of. You just have to append your environment variable, that is Keras backend, to the backend that you want. Seamless switching, just as the slide before, you can use the os.environment and switch from one backend to another. So that's very easy. And also this Keras.ops. And this is an example where I try talking about the NumPy API mimicry. So np.arrange gives me five, like an array of 5, and keras obs.numpy.arrange gives me a array of 5. But note that this is a tf.tensor because the back end of keras is, I have set it to TensorFlow, so that's a tf.tensor and not just a numpy array. But the interesting thing comes here. np.softmax on x or numpy does give me an attribute error because numpy does not have an attribute called softmax. But as you might have known, that softmax is a function that has been used like greatly, and it's an immensely powerful function in the neural network side of things. So keras.obs.softmax gives you another tensor which is actually the softmax of this array. And this only like I have covered this in my slide just to show that with keras you not only get the numpy flavor of things, but also another parallel of neural network functions which are very important for any deep learning engineer or practitioner. So keras.ops model also helps you in building keras like deep backend agnostic things. So if you see token and position embedding, this is a code which had a lot of tf dot arrange or maybe a torch dot arrange or something like that, which is very not backend agnostic, which was previously taking care of only TensorFlow or maybe only PyTorch. Now when you do ops dot arrange and you set your backend to any of the backends that I have mentioned, it knows that ops is going to take TensorFlow, or maybe it's going to take JAX, or it's going to take NumPy, and it's going to understand that, hey, this is the backend. I need to work on this backend rather than using just hard coded TensorFlow or Torch or JAX. So this also helps you create your layers or classes or even models which are agnostic of any backend that there are, and it's highly customizable. So you just have to understand how keras works to extend layers, and everything is just taken care of. And advantages, our first advantage is that it's cross framework data pipeline, so there is a support for that. And what do I mean by that is, with just tensorflow.keras we always used to kind of go into tf.data.dataset, which is a package from the TensorFlow side of things. But if you are an avid Torch user, you might be familiar with torch.utils.data.data loader. If you like NumPy arrays, we have NumPy arrays as well. Pandas data frames. If you are coming from the Kaggle side of things, you have seen a lot of data frames and hopefully have worked with them. And there is this new thing that Keras has come up with is called PyDatasets, which lies in the keras.utils.datasets. So all of these data pipelines can be used with your models to evaluate or maybe train your model. And why this happens is because now Keras does not need to know which whether I'm going to use TensorFlow or whether I'm going to use JAX or Torch. You can just work on any of the three powerful platforms, and the cross framework strategy or paradigm helps you to also support cross framework data pipelines. So that is a good and a very big advantage, which I have personally found to be very nice. And coming off at 2023, it is an era of large language models and large things all of a sudden. And turns out that people do not like training everything from scratch. So they need pre-trained models, which they can fine tune on. So Keras CV and NLP has a bunch of pre-trained models for specific to computer vision, specific to natural language processing, or maybe even the amalgamation of the two. And you can get them out of the box. You can train them with the backend that you want, and everything is going to work. And another thing that I really like covering in my talks is progressive disclosure of complexity, which is a phrase which is thrown quite often in the Keras side of things. So what do we mean by that is, you, if something is complex, you don't have to face the complex side of things right at the get-go. You can progressively disclose that complex things by starting simple and customizing as per your needs. So there is something called sequential modeling. There is also something called functional modeling, and there is another thing called custom modeling. So Keras works with sequential, which is just a layer of a list of layers, which is turned into a model. Functional is kind of like a directed acyclic graph, and custom side of things is where you want very fine grained um, control over the entire training step. So that is how you go from simple, whether that is sequential, you customize your things with functional, and also if you need fine grained control, you can always go to the train step, that is the custom side of things. So that is good. Another good advantage that we have in Keras 3 is the new stateless API for pure functional programming. And if somebody has already been introduced to JAX, they know that JAX differs at a very basic level from TensorFlow and Torch by being inside of the pure functional programming paradigm, which just means that they don't like states, or they like pure states. So no there should be functions in which you pass the state and the state should be updated and returned, rather than having a state of the class on its own. So with that, what you need is something called stateless APIs. So Keras previously used to work with TensorFlow, and as you have guessed, Keras was a stateful API. But now with the introduction of JAX inside of Keras 3, it has this stateless API to support JAX and also pure functional programming. And that is, this introduces a lot of flexibility to coding. And if you are proficient with pure functional programming, it might come out as a piece of cake to walk through the code of Keras. And also, something which I have recently learned is that distributed training is very easy with Keras now. And the first class citizen being JAX. And JAX is known for its powerful distributed training on TPUs and maybe GPUs. So the people at Keras are working really well on distributed side of things. And like recently, there was this community event where people were announcing about Keras.distributed. The APIs are going to be a little buggy at this point in time, but they are going to straighten it out, and it's going to be a very intuitive design. So that I am very excited about. Talking about that, I am going to straight away go into the demo, which is image segmentation with Keras 3. So the task is, you have an image like this, and you have your ground truths, that is the segmentation map of the dog or maybe cat or whatever. And you will have to create a model which gets this image and does the image segmentation, right? So let's get started. The first things first, what I'm going to cover is the Oxford Triple IT PET dataset. This is a dataset which contains about 5,000 data points of dogs, 2,500 data points of cats, and also trimaps. These are this. And we will use the JAX backend. So as I have already, like in my past slide, I have already told about how Keras is very agnostic to backends. You can always import OS, set the Keras backend environment variable to TensorFlow, JAX, or Torch, and everything works. And we will understand how to build the data pipeline. So remember, I talked about PyDataset, which is a new introduction to the Keras side of things. So we are going to use that. And what we did here is that we created a class called Oxford Pets, and this class directly takes or inherits from keras.utils.py dataset. And the only things that you need to understand with this dataset pipeline is that there is this init where you initialize things. There is length that gets you the length of the not the length or the size or how many data points you have inside of the data pipeline. On epoch end is a function that understands that, hey, the epoch has ended. What am I going to do next on the start of an epoch? And get item is just to sample from the container of data that you have. So you have got to write these 4 functions, and the data pipeline is ready. So the data pipeline is PyDatasets. You can also use tf.data.datasets and PyTorch data loaders. It will work off the bat. And we are also using PIL for image processing in this example. So to begin with things, data pipeline, the initialization part of things, we are going to initialize the batch size, the image size that we want. We also want to know where the image is stored in our memory, so the input image path. Also the target image path, because the input is an image while the target is just a segmentation map. So we need both the paths of these images inside of our memory. The indices, that is which index I am on, and also a parameter called shuffle, so whether or not we want to shuffle our entire data set. And this is really something that you all must do, because if you provide a deep learning model same the data in the same order, it's going to understand that pattern, and it's not going to be regularized quite well. So you have to shuffle this container of images while you're feeding that into the model. So len is basically all the image paths, the length of the image paths by the batch size. So it gets you how many times you're going to iterate on one epoch. On epoch end gives you the logic of what you need to do after an epoch ends. So what we are basically going to do is we are going to basically shuffle the data that I have covered. So you just take this container of images and shuffle it, and then you're going to get the item. And this is I know that this does not get into the slide right away, but I'm going to open source the slide just after my talk, so no need to worry. And this is all already there inside of a GitHub repository, which I'm going to share as well. So get item does basically you have this data container, you sample out how many images you want, you batch it up, and you just give it away to your user or to the model. So that's basically what is happening in get item. That covers the data set building side of things. Now we want to build a model, and to build a model we have used functional API, because we wanted a kind of a unet wherein you have a lot of things going from one layer to another. It's just like a directed acyclic graph. So we wanted to cover the functional paradigm. To build the functional paradigm, it's as easy as creating the inputs and the outputs and do a bunch of computations here, and use the Keras.model API, give the inputs, give the outputs, and Keras is going to take care of the entire graph, formulate the DAG, and it's going to create the model. And it's that easy. So what the model building steps would look like is that it's a unit model, and as I have already covered, it's going to be the same with tf.keras, so it's a drop-in replacement. You can the model is being built using the functional API. You can also call the optimizer callbacks and losses, which you need to fit the model, that are there in the tf.keras, and they are also backend agnostic with the keras 3 announcement, so don't have to worry about that as well. And unless you have something very specific to TensorFlow, porting models from TF Keras to the multi-backend Keras is like a piece of cake. So if you have a model already and you want to port it from maybe TensorFlow Keras to the backend agnostic Keras, just have to do a bunch of keras.ops or something like that, and it's going to be ported quite easily. So we'll build our models, and this is the first thing that you've got to note. That is, we are going to build a unet. So a unet has a kind of conv blocks which takes in images and downsamples it, and you have a deconv block which takes this latent embeddings and then upsamples it into something which is very close to what you would have of the image. So conv block is just activation, dropout, conv2d, and batch norm, while upsample, which is deconv, is activation, dropout, conv2d, transpose, and batch norm. So the only change here is with conv block is conv2d to conv2d transpose, and that's basically it. And a bunch of hyperparameters, as in the paddings, the kernel size, and whatnot. So that we are going to take care of. And with that, we just get the inputs, do a bunch of conv2d, and then again conv2d transpose and blah blah blah, conv blocks and upsamples. And here you have it. You have your pet model, which is a unit model, and you can just call the get model with the image size and number of classes, and you get the model back. And what I like most about Keras is its easy model.fit API, which basically hands you an API that accepts the training data set, also the validation data set, the number of epochs, and also some callbacks that you want. And it's going to train the entire model. And this is this is the pet segmentation with Jack's backend. That is our model performance on validation dataset. So once you give in images, the ground truth looks like this and the prediction looks like this, which is not bad for a very quick iteration. I think it was trained on 10 epochs, but I may be wrong. But it's really less data and it's really less epochs. So as much we could have squeezed out of our weights and biases. So that's what it is. And what we did here is that we took the validation dataset dot take one, that is one batch of the validation dataset. We took the sample images and sample masks, and we did a model.predict. That is, we are telling our model that, hey, you have been trained. Now take these images and give me predictions. So after I get the predictions, I do a keras.ops.argmax, and that gives you the prediction for the most probable prediction that is out there, and you get that from argmax, and you just plot it using our visualization tools like matplotlib, or maybe you could also do a keras cv.visualization. It's totally up to you. So with that, if you want references, you can absolutely go to the announcement page of Keras Code. You could also do what is Keras Code by PyImageSearch, and this is a shameless plug in which me and one of my very best buddies out there, Ritik Raha, who is also a colleague of mine at PyImageSearch, we both have worked on this tutorial, what is Keras Code, and this is a nice read, not being biased. And also distributed training, that is a Kaggle kernel, which has been written by Akash Kumar Nayan himself. He talks about how you can leverage the entire model and you can shard things, you can use a very efficient data pipeline, and you can use it on TPUs and speed up the process. So you could definitely look into distributed training Kaggle kernel as well. And just to end my talk here, I want to acknowledge Francois Cholet, who is also the creator of Keras, for building such an amazing community, not only really good framework, also the ML developers program and the GDE community for reviewing and a good amount of discussion. So with that, I am going to end sharing.
Thank you, Aritra, for the amazing session. It was really exciting. I really enjoyed it. So I have some questions here that we may want to welcome, that we may want to ask you around Keras and around Jax and even on community. So I'll start with Keras.
Yep.
And how is Keras working to make deep learning more accessible to a wider range of users, which includes beginners and even the non-programmers?
Right. So a motto of Keras was it's deep learning for humans, and that is a very good way of saying that Keras does not want only researchers to come in or engineers to come in. They want us humans who just have the knowledge of doing things getting inside of Keras, and it's very, very intuitive. So what Keras' basic philosophy is that it discloses complexity very progressively. So if you don't have a lot of prerequisites about deep learning, you could maybe just get a bunch of NumPy data sets, work with them with the sequential API, with the functional API, and slowly but steadily understand the workings, and also get to show off with your friends that, hey, I built a model which is going to predict whether an image has a cat or a dog or something like that. So what I try to come to is that Keras' community and also its guidelines are something which really make it very beginner friendly, and how you can come in from any backgrounds.
Amazing. I think I like the idea of progressive disclosure of complexity, and this idea that you can have someone who is a beginner who probably is just starting use the same components as someone who is working at way more or working at this company that is doing amazing things with Keras, and all of them have
Absolutely.
equal access to tools. But there is progressive disclosure of complexity. I think it's really a nice idea. So since you've worked with the Keras team, what's really the main motivation behind the development of Keras core? Knowing that we've been having Keras running on top of TensorFlow, and even before that, we used to have Keras running on Theano. Then we came to Keras that's tightly tied to TensorFlow. So what's the main motivation behind the development of Keras core or Keras 3?
So the main motivation, I can't like pinpoint to one main motivation, but there are many. One thing that I feel like, which was motivation towards getting into Keras Code or maybe Keras 3, is that there are a bunch of numerical libraries that are doing a lot of good things. So to talk about just JAX or maybe just PyTorch, they have their own nuances because people from the research side of things like PyTorch more than TensorFlow. And it's also some and Jax is also kind of getting a lot of traction because of its use cases in distributed training and parallel training. So Keras just wanted to be, devoid of all this animosity between deep learning frameworks, and he just wanted to harmonize the good parts of every deep learning framework. And you, as a human being or as a user of Keras, can decide on what backend you want to use rather than being tightly coupled with only one backend, and you have to understand how TensorFlow works and what are the upsides and downsides of it. So if you think TensorFlow is good at one thing, and for me TensorFlow is really good at serving and deployments with TF Lite and stuff like that. Jax is really good at TPU side of things, so you can efficiently train your deep learning models with data parallelism and TPUs in Jax. And PyTorch is good at its own side of things. So if you can mix and match, and where you could leverage this function out of this platform, that's where Keras comes in. It just takes away all of these prerequisites, and you can train your model on Jax, deploy your model on TensorFlow and whatnot, and even take a researcher's model which is there in PyTorch and use it inside of your uh, TensorFlow script. So everything is kind of very seamless. The switch is seamless, and that is how I think one of the biggest motivations of getting into Keras Code.
Amazing. Because I know that we've been having people who are using PyTorch, and they're saying that
Mhm.
what they miss most in the other side is probably Keras. Or we've been having people who are
Right.
using Keras and TensorFlow in the sense that they can't
Mhm.
leave Keras and TensorFlow, even if there are some amazing things on PyTorch, because they want to
Right.
still enjoy Keras. So I think the idea that you can switch backends the way you want and use components from different platforms, I think it's a great idea. And thank you for answering that one.
No worries.
And on top of that, what are the benefits of using Keras Core over the standard Keras API? Is there some additional benefit on top of it?
So the biggest benefit that you can currently have with Keras Core rather than Keras API, that is tf.keras, I feel is the data pipeline. So think about it. If you are a researcher or you go into a research lab, which already has a data pipeline set in maybe Torch data loaders, and it is pristine, you don't have to work one bit on that data pipeline. But now you want another model which has been created like 2 days ago, which is in Jax, and you want that model to kind of ingest data from this Torch data pipeline. You can just wrap your Jax model with Keras, and Keras is not going to prohibit you from using your Torch data loader. So the data pipeline cross framework data pipelines is something which I enjoy a lot, and that's like one big boost that you kind of get right off the bat. Does that answer the question?
Sorry, I lost you for some few seconds. I think someone was calling me. Sorry about that. I hope you can
No,
still hear
not a
me.
problem. Yeah, I can.
All right. Okay. Perfect. Now I've really enjoyed using tools like Keras Tuner that can
Mhm.
help me to uh, optimize my hyperparameters. Of course, I can build my
Right.
model, have like a base model, but probably I may want to have like this hyper model somewhere, and I can enjoy using it, and then it can find a way to get for me the optimum hyperparameter to use. And also, since you've been working with Keras and we've seen your work online, is there any particular thing that you really enjoy or you love about Keras?
Uh, there are a lot. So the one thing that comes to my mind about Keras is the design of Keras APIs. It's as easy as reading English. If you are anywhere in the world who just knows English and gets into the Keras repository, I think there will be some code that you just understand without even having the knowledge of deep learning, because the APIs are written so well and it's so intuitive that they just make sense, right? And this is also something which is kind of a blocker for a lot of pull requests that you go to Keras, because the developers there always want you to write good and expressive and also quote unquote readable code, because once you write a code, it's going to be read a lot of times. So one key mantra that Francois told me about his writing style is that write code so that you don't need comments, and as soon as you understand that you are coming to an obstruction of writing code because it's getting too complicated, only that is when you write comments. So in that case, you don't fill your entire code with a lot of comments. You're going to make it readable enough so that you don't need comments in the first place. But if it's too complex to write your code, write one line of comment, and that's not only going to bring your code down to a few lines, but also is going to help you get more and more readable code out of your entire process. So that is something which I love about Kits.
Yeah, I'll also enjoy the same about Keras, in the sense that you can find you can have when you're writing Keras, you can find that the concept is really deep and you have a lot to cover, but Keras find a way to make it simple in a
Exactly.
way that you don't have to worry about. I mean, the theory is big, but the way you write it is so small in size. For example, the way you write the loss function or
Mhm.
have the optimizer, if you see what's in the background, it's really huge. All the theory is very huge, but Keras make it so simple for you. So I also enjoy the same. And is there anything you'd want to change or you'd want to see different from what we currently have in Keras?
Not something to change, but I would also like to see a lot of other platforms coming in if there is a good amount of hits on some backend that people really want Keras people to do. I would like that getting inculcated into Keras. And it's very easy because I was the one who did the entire backend for NumPy. So it's very easy if you think about it. But yeah, so I'll just leave it to there. Like, if somebody likes a backend that they want support from Keras, you just need to ask, like, open an issue and say that, hey, this is a backend that does this, and we really want Keras to have it. We are going to take care of it. So something like that.
Mm, amazing, and congratulations on working on that backend.
Thank
Because
you so
I
much.
know that's welcome. I know that you today you can use Keras with NumPy. The only difference is that with PyTorch, JAX, and TensorFlow, you can do automatic differentiation, but with NumPy, probably you
You
can do
cannot.
automatic differentiation. Yeah, but you can still do inferencing with it, which is really amazing.
Exactly.
So
Right.
we're really happy to have amazing people like you who are
Thank you.
continuously helping us build these tools. Okay, so at this point, I'd want to hand it over to the next person, who is Daisy. Hi, Daisy.
Hi, Gessa. Thank you. Looks like I got back in good time. Uh, Great. So, really, Aritra, thank you very much for talking to us through Keras. Now we'll be having a
No
look
worries.
at the Jax questions. So, how can we use Keras and Jax together to build and train deep learning models?
So that is something which I already covered in my slide. So it's very simple. You just have to import OS. That is a package that helps you work with your operating system. And you have a environment variable called Keras backend, and you set that to your favorite backend. And my favorite backend is Jax at this point in time. So you can just do an os.environment Keras backend is equal to Jax, and everything is going to work. So that is how you kind of tie Keras as a UI to Jax backend and train your model. So that should perfectly work.
Great, thank you for that. In addition to that, what else would you say is the sweet spot between Keras and Jax in such a way that this can benefit developers and researchers in the deep learning community?
Okay. So what I felt like, and this is my opinion completely. So once I started understanding what Jax was and how Jax was, I found that there was this need for a little bit abstract layer on top of Jax. So what I mean by that is Jax is very low level, in which you have to create your own layers. You have to create your own weights and biases, and with tree maps and stuff like that, you've got to make the entire training pipeline on your own. A lot of things that goes into it. Once you understand that, really need to be a good deep learning engineer to understand all of the Jax's workings to finally get into a point to train a model. But what Keras does with Jax is that Keras behaves like abstract on top of Jax. So you don't have to understand a lot about deep learning to get into Jax. You just need to create a model with Keras, which is very simple. You can do it in maybe 10 lines of code, and you just have to attach your Keras backend to Jax, and everything is getting populated into Jax. You can use the stateless API of Jax, and everything happens in the background, which is taken away from the user. So you don't have to dive too deep into Jax to understand the workings. You can use Keras to work on Jax. So that is kind of like the absolute sweet spot that Keras provides for Jax users.
Great. Thank you for that, Haricha. So,
Mhm.
as we compare the different platforms, so what are the key differences between Keras with a TensorFlow backend vis-a-vis Terax with a JAX backend in terms of performance and flexibility?
Right. So a really good way of understanding this is that Jax is inherently very efficient because of the way it is written, and also due to the fact that it is JIT. Most of the things are JIT compiled. Once you harness that efficiency with Keras, you will see that most of the times, and it's not all the times, most of the times, if you run a model with TensorFlow's Keras, and if you run the same model with the same data pipeline with the same optimizer, everything remains the same, but just the backend differs to Jax, you will get an instant speed up of the training pipeline due to the fact that it is like everything is compiled off the bat, everything works in Jax backend, and everything is good to go. And there is this other little thing that I wanted to cover is that with the Keras 3 announcement, TensorFlow code is also compiled off the bat. So if you use TensorFlow's like Keras's legacy, that is tf.keras, which was once used, and versus Keras Core's TensorFlow versus Keras Core's JAX, you will see an increment in the efficiency step by step. So the least in speed would be the legacy Keras, and that would be the second in line would be tf.keras, that is the Keras Core's TensorFlow, and then you get JAX. So there is this instant speed up that you absolutely enjoy while you are training your models.
So best way forward would be Keras with the Jax Keras tree.
Yep.
That is great. Um, so for someone who's trying to get into deep learning, what advice would you give them if they want to be proficient with Keras and Jax?
So somebody who is getting into deep learning, I would ask them to first have a course or a book in hand. And the best book to, I at least I enjoyed a lot is Francois' Deep Learning with Python. So he has written a book about deep learning, which is very fluent and talks about a lot of different things. And I think he's also currently working, or maybe he'll work on another version of this book with Keras backend. But right now, it talks about TensorFlow's Keras, and everything, every API that he covers is already there. So that is a very good place to begin with. There is also this Keras IO, which is the website for Keras, keras.io. And you can go into that and see examples yourself, guides yourself. There are a lot of helpful starter guides which can get someone to speed who is just beginning. So that might help as well.
Great. Thank you. I didn't get the name of the author for Deep Learning with Python.
Oh, so his name is Francois Cholet, who is also the creator of Keras.
Great. Thank you. So finally, I know you may have mentioned this already, but in addition to the resources shared, what else can people use to learn more about Keras and Jax?
Okay, so now it's time for a shameless plug. So we at PyImageSearch love writing about blogs and also a lot about frameworks. So we have a entire blog post surrounded around what is Keras code, and we have a bunch of other applications like object detection, image classification done with Keras. But mind you, those Kerases were not Keras 3 Keras, but legacy Keras, which talks with TensorFlow. And it's not going to be a problem because it's a drop-in replacement, as I mentioned in my slides. Another little thing that I also wanted to mention is that we have a series on Jax, which is open source. I'm going to share the link with the hosts so that you can go into YouTube later and maybe update. So what this is it's a series on Jax which has been reviewed by people from the Jax community themselves, and this helps you understand how Jax came into existence. You just don't like it; just does not comes out of the bat. There needs to be a reason for the creation of something new. So we not only understood why there was this void which led into the development of Jax, but also how you, if you know what Jax is, how you can train a very basic model and then scale it up. So I think that is going to be a very good place to start with Jax and also Keras.
Thank you, Aritra. That's very insightful. We'd be sure to share the resources shared with the
Mhm.
community on YouTube and also using our mailing list. Thank you. And I'd
Absolutely.
like to now call upon Philomena.
I think you're on mute, Philo.
Ah, okay. Thank you.
No problem. Yeah.
Thanks, Daisy, for handing it over, and thanks for those questions. Thanks, Aritra, for that presentation. It was quite informative. I'll make sure to go over it again just to be able to grasp all the
No
concepts that you
problem.
talked about. Yeah. So I'll take you through some questions on community and collaboration.
Mhm.
So since you've been in this field for a while, right? And I'm sure there's some people who are watching and wondering how they can be a part of the Keras community. So what advice would you have for people who want to get involved in the Keras community, and where should they start?
All right. So with this, I share another another link with the hosts, and this is going to right. So this is the GitHub repository for Keras, and people who want to be directly involved into this into the community can get into the GitHub repository, go into the issues tab, and see good first issues, or maybe just get into the discussions of what people are facing, like where are people facing trouble, how can they solve in, how can they just get into the discussions and maybe talk to people who are currently working on something. So what I have found very useful is that ask questions where you think you can answer, and also ask questions where you think you cannot answer. There are a lot of people who can ask questions when they have an answer to that, because that is what makes people confident, because we have answers, why not ask questions? But there are a lot of people who are just starting new, and Keras is a very uh, how do you call it, the community is very good. It's not it does not shoo away people who are not really good at deep learning. Rather, they take them up, pick them along, and go into the roads of open source. So please don't feel shy to ask a question. If the question is a valid question, and it's a reasonable question, there you will find somebody chiming in and helping you along the way. So that is kind of what collaboration is, right? So that is something which
Yeah.
Keras does a lot.
Okay, great. I think you answered most, if not all, the questions on collaboration, all wrapped up in one. But maybe how is the Keras community fostering more collaboration between researchers, practitioners, and developers? And is there maybe room for improvement on that?
Right. And
Yeah.
this also links to one of the questions asked earlier, which is, uh, if you think about it, right now the deep learning space is kind of conflicted between using platforms, wherein
Mhm.
researchers like Jax and PyTorch more, uh, people who work on product side of things like TensorFlow more, because it's very easy to deploy models on TensorFlow and whatnot. But how to harness and harmonize everything into one is where Keras comes in, wherein people from the researcher, like research side of things, people from like industry come in, and they can just use Keras. They can talk about open source inside of the communities, and everything works in tandem. So that is something which I have seen a lot, and that is why I am such a big, you know, how do you call it, a very big contributor, as well as somebody who likes Keras a lot. So that's something which I do a lot.
Okay, great. It's amazing to hear that we have such a supportive community around us, from beginners to the experts. So, yeah, thanks so much, Aritra. Again, I'll hand it over to Daisy, so that she can conclude for us the session.
Thank you very much, Philomena and Gessa, for walking us through the questions, and Arita
Or
really for being
Ngesa.
able to answer them. So,
Thank you, Philomena. And also thank you, Aritra, for the amazing session. I've really learned a lot, and I'm sure everyone who's joined the call have also learned a lot. And we'll share all the links that you've shared with us with everyone. And hopefully we'll be able to even have more physical sessions, to do even more hands-on sessions. But we're very grateful,
Absolutely.
and thanks so much for joining us. Yeah.
No worries. Thank you for having me.
Thank you, and have a wonderful day, evening. Good evening, everyone.
Bye
Bye.
bye.
Take care.
is it that you can't hear me?